Welcome. Let's check out question 6. So when we left off, it said, please find angle 1. So when I look in this picture, here's angle 1. It says find angle 1 that would make these lines parallel. So in fact, if we have a setup where we're not told these two lines are parallel, but we're told make them equal so that it would make them parallel, that's called the converse theorems. Okay, so we know that if it makes a z, these angles are alternate interior angles. And if these are parallel, these alternate interior angles, so the alternate interior angle theorem would state that this angle and this angle have to be equal. So they already called this angle 1, so I'll call this angle 2 and angle 3. So we know that angle 2 and angle 3 have to be equal if those lines are parallel. Well, they're not telling us they're parallel. They're saying, let's pretend they are parallel. How could we make these lines parallel? So to lock these lines into place would force these two angles to be equal. And that's technically the converse alternate interior angle theorem. All right, so by setting them equal to each other, and I'm going to do this on another piece of paper, but what's important here is notice these angles. Once I know what angle 2 or angle 3 is, I still don't know what angle 1 is. So I'm just going to draw a picture off to the side. Once I know what this angle 2 is, then I can solve for angle 1 like the last question, because those should make a linear pair. So I'm going to make a quick sketch, make a little z. So I'm hoping that M and N are parallel, and they would be if these two angles are equal. And then this is my angle 1. So my angle 2 and 3, I'm going to set equal. Angle 2 is equal to angle 3 because of alternate interior angles. And I'm really doing the converse here. All right. So now angle 2 is 26 plus 2x, so just substituting 5x plus 8. And those are addition signs, so we get 3x by subtracting 2x. And let's subtract 8 on both sides. Okay, so x is 6, not my answer. I'm being asked to find the measure of angle 1, but I have solved the mystery of the x. So we were told that the measure of angle 2 was 26 plus 2x. So now that we know what the x is, we can substitute it in. So the measure of angle 2, we can figure out. So the measure of angle 2 would be 26 plus 2 times 6. So 26 plus 12 would have to be 38. So now that we know that this is 38 degrees, we can pretty much figure out what angle. So angle 1 and angle 2 happen to be a linear pair. See how they make a straight line? Oops, that needs to be an equal sign. So we don't know what angle 1 is. We could call that x if we wanted. Well, we already had a letter x, but who cares? Okay, so we don't know what angle 1 is, but we know that angle 2 is 38. And so when we do that, okay, so our missing angle, angle 1, would have to be 142 degrees. We could double check our answer. Let's just add the two together. Yep, and you get 180. Perfect. So that's our question 6. Looking good. Now for question 7. This one I think would need to be on our piece of paper, so let's take a look. When I look at the question, it says select the statements that are missing. So in a proof question, we need to understand each line. So what they're saying here is angle ABD. So that's happening at B. So ABD, that's this angle. And ABC, so that's this angle, also happening at B. These two angles form a linear pair. And that's just like the last question. They're also saying CBE, this angle right here, would also make a linear pair with the purple one, and I would agree with that. So it's interesting. The yellow one and the purple one make a linear pair, and the gray one and the purple one make a linear pair, and I think that makes sense because the gray one and the yellow one are equal to each other. So now it states angle ABD, the yellow one, and ABC, yes, purple one, are supplementary. And that's the linear pair postulate. We know that these two angles, because they form a straight line, should be supplementary, which means they add up to 180. And so they're just walking through each step one by one. Now, what step could they have taken that would have looked like substitution? So notice here, they said this stuff is equal to 180, and this stuff is equal to 180. So we know if they're both equal to 180, we should be able to just put them equal to each other. So I think that's what they want here. So I'm thinking that if this is equal to 180, then I can just substitute this big clump of stuff in where I see the 180. Okay, now let's keep going. So I substituted where I saw the 180, I substituted these terms. So they're saying the yellow angle plus the purple one is equal to the gray one plus the purple one. Now it says they subtracted, subtraction property. So if I were to subtract, notice I have this on both sides. Yeah, I've got this term on both sides. But it does look like they subtracted whatever the measure of ABC was on both sides. And that's what subtraction property is when you subtract the same thing to both sides. So notice if this went away, then I would have had that. So I love this. I like what I wrote there. Now I just have to make sure that I've got the right thing circled here. So as I look, ABD, ABC, CBE, no, CBE, ABC. Perfect. So D matches what I'm looking for. Okay. Now let's try question 8. And the last video will have question 10. There was no question 9. So when I look at question 8, I notice that it says, what is the value of D that would force E and F to be parallel? So we don't know they're parallel, but if we locked them into place, what would D need to be? And so again, this is this converse theorem. Now the angle relationships between the two angles I have appear to be corresponding. So this angle here, if I slid it down there, should be a perfect match. So this is converse corresponding angle postulate. So if I called this yellow angle 1 and this one angle 2, we know that angle 1 and angle 2 would be equal using the converse corresponding angle postulate. So if I force them to be equal, I would in fact have two parallel lines, which is kind of the reverse of the regular corresponding angle postulate. So let's do it. Let's set them equal to each other and solve. And we need plenty of room to do that. So question 8 on our regular piece of paper here. If we have two corresponding angles, angle 1 and angle 2, if they're equal, then this would allow the two lines to be parallel. So angle 1 is equal to angle 2. if we force them to be equal, we would make the lines parallel. So angle 1 substituted is 5 2d minus 3, and angle 2 substituted is 6d plus 11 plus 2d. So I don't really need the, I guess you could say there's a 1 outside. If I distributed a 1 to each term, I still just have the same terms here on the right. On the left, I need to distribute the 5 to both terms. So I'm going to go ahead and do that. 10d minus 15. Now I need all the d's on one side, but it looks like I can combine these terms that are alike on the right. So before I get everyone on one side, the 6d and the 2d could combine to make 8d. Okay, now this is more like what we're used to. If I subtract 8d on both sides, and I add 15 to both sides, I get d is 13. And now I'm back to rereading the question. What is the value of d that would in fact make them parallel? And so there it is. My answer choice was B, that if I set these equal. Now I'd like to just double check my answer quickly. If I plug 13 back in for angle 1, so 5 times 2d minus 3, that'd be 5 times 2 times 13 minus 3. So 5 times 23. Okay, so I get the answer 115. If you'd plug the other one back in, you should get the same number. Thanks for joining us. Check out the last video.